Welcome friends to SSC CGL Tier 2 level quick algebra problem solving. This is Atanu Chaudhary of SureSolve. Today in this first part, we'll solve question 1 to question 5 of SSC CGL Tier 2 solution set 2 on Algebra 2 from suresolve.com. Let's solve the first of this challenging set of problems. Question 1 is the number of possible values of x in the equation root over x square minus x plus 1 plus 1 by root over x square minus x plus 1 equal to 2 minus x square is option A 1, option B 2, option C 0 and option D 4. The two terms on the LHS being inverses to each other, if you raise the equation to its square, you would get rid of the square root. But then the resulting equation would be too complex to deal with quickly and elegantly. Which way to go then? At this point you remember the property of minimum value of sum of inverses of positive variable as 2. For convenience you replace p equal to root over x square minus x plus 1 and convert the LHS to p plus 1 by p. A quick check ensures that p is indeed positive for any value of x. For all negative values and all values of x greater than or equal to 1, it is obvious that root over x square minus x plus 1 will be positive. And when x is positive and less than 1, 1 minus x will make root over x square minus x plus 1 positive. LHS p plus 1 by p with positive p will then have its minimum value of 2 when p equal to 1 or x equal to 0. Your attention shifts now to the RHS and you find that its maximum value is 2, and that also occurs when x equal to 0. For all non-zero values of x, 2 minus x square is less than 2. Simple conclusion is only when x equal to 0, RHS can become equal to the LHS and the equation is satisfied. That is, number of possible values of x is just 1. Answer is option A 1. Let's explain briefly how p plus 1 by p gets its minimum value of 2 with positive p. You have the sum of inverses as p plus 1 by p equal to p square plus 1 divided by p. When p greater than or equal to 1, p square in the numerator will increase much faster than p in the denominator, starting from the value of p equal to 1 when minimum value of expression is 2. For dealing with values of p less than or equal to 1, let's assume p equal to 1 by q and the original sum of inverses is changed to 1 by q plus q equal to q plus 1 by q. The form of the sum of inverses expression remains unchanged. In the second case, consider all values of p where p less than or equal to 1 and q greater than or equal to 1. By the same logic as before, the expression now will increase indefinitely from initial value 2 when p goes on decreasing starting from 1 and q goes on increasing starting from also 1. In this case also then, the minimum value of sum of inverses remains as 2. Thus, for all possible positive real values of p, the sum of inverses p plus 1 by p will have its minimum value as 2. Let's summarize now the important concepts and techniques that we have used for solving this awkward problem. These are key pattern identification that LHS is a sum of inverses, dummy variable substitution, minima of sum of inverses, pattern identification of RHS maxima, maxima minima equalization of RHS and LHS, and mathematical reasoning. Let's solve the second problem. Question 2 is, if p plus 1 by p equal to 5, then the value of p to the power 4 plus 1 by p square divided by p square minus 3p plus 1 is option A 50, option B 55, option C 70, and option D 110. To start with, following algebraic expression simplification strategy, you decide to simplify the target expression and express it in terms of p plus 1 by p as much as possible before substitution of the given value. This is a logical step because if you do that, you can directly substitute the value 5 for p plus 1 by p. With this objective, when you examine the target expression, you immediately discover the pattern that by the simple action of dividing both numerator and denominator by p, you get a very favorable changed target expression as p cube plus 1 by p cube divided by p plus 1 by p minus 3 equal to half multiplied by p cube plus 1 by p cube. With one shot, you have killed two birds, so to say. Now it is an easy situation. Just express p cube plus 1 by p cube in its modified two-factor expanded form in terms of p plus 1 by p as half multiplied by p plus 1 by p multiplied by p plus 1 by p whole square minus 3 equal to 5 by 2 multiplied by 25 minus 3 equal to 55. Solved in no time. Answer is option B, 55. Important concepts and techniques used for solving the problem are target expression simplification before substitution following strategy of algebraic expression simplification, pattern discovery of transforming both numerator and denominator at one shot by dividing with p, and modified two-factor expansion of p cube plus 1 by p cube wholly in terms of p plus 1 by p. Let's see the third problem. Question 3 is, if root over 4x minus 9 plus root over 4x plus 9 equal to 5 plus root over 7, find the value of x. Option A is 3, option B 4, option C 5, and option D 7. On analysis of the problem, you find that if you raise the equation to a square, the square root remains only with the middle term for both LHS and RHS. Equating the square root terms or the non-square root terms between the two sides of the equation will then give you the solution easily. So raising the given equation to the power of 2, you get 4x minus 9 plus 4x plus 9 plus 2 square root 16x square minus 81 equal to 25 plus 7 plus 10 root 7. Or 8x plus 2 square root 16x square minus 81 equal to 32 plus 10 root 7. Equating the non-square root terms of LHS and RHS, you get 8x equal to 32 or x equal to 4. You can also verify this result by equating the square root terms of LHS and RHS or substituting value of x, which is easier and faster. Answer is option B, 4. Important concepts and techniques that we have used for solving the problem are mathematical reasoning, limiting square root terms on both sides of the equation to 1 by raising the equation to its square, and comparison of like terms. Let's solve the next question. Question 4 is, if square root 2x minus square root 3y equal to 0 and square root 7x plus square root 2y equal to 0, then the value of x plus y is option A 1, option B 2, option C 3, and option D 0. Don't get stopped by the variables under square roots. Essentially, you have two linear equations and you can easily eliminate one of the two variables even under square root by multiplying with suitable factor and adding or subtracting the two. Choose square root y to eliminate. Multiply the first equation by square root 2 by 3 and add the two equations. The result is square root x multiplied by square root 4 by 3 plus square root 7 equal to 0. So x must be 0. Substitute this value in any of the two equations and you will get y also as 0. Finally, x plus y equal to 0. Answer is option D, 0. Important concepts and techniques that we have used for solving the problem are abstraction in treating equation in variables under square root as linear equation and solving two linear equations in two variables. Let's solve the last question now. Question 5 is, find the remainder when x to the power 5 minus 9x square plus 12x minus 14 is divided by x minus 3. Option A 56, option B 184, option C 0 and option D 1. When you divide say 1312 by 7, you repeatedly take out factor of 7 first from the first two digits and then from the resultant remaining digits till you get a remainder that is less than 7. In a sense, that is how you divide one number by another. Algebraic expression division is no different. We have given the name of continued factor extraction to this never-failing method. By this method, the factor of x minus 3 will be extracted from the given expression step by step by taking up the term with the highest available power of x at each step. And at each step, the factored part will be dropped as we need to find only the remainder. This will reduce the degree of expression by 1 at each step, making it simpler and simpler, finally yielding the remainder as an integer at the last step. Let's apply the continued factor extraction on our pair of expressions. First step target is x to the power 5. And first step result is x to the power 4 multiplied by x minus 3 plus 3x to the power 4 minus 9x square plus 12x minus 14. The plus 3x to the power 4 compensates the second term within the brackets needed to form the factor of x minus 3. At the second step then, the target is 3x to the power 4 and the expression of interest is 3x to the power 4 minus 9x square plus 12x minus 14. Take out another factor of x minus 3. Result is 3x cubed multiplied by x minus 3 plus 9x cubed minus 9x square plus 12x minus 14. At the third step of factor extraction, the result is 9x square multiplied by x minus 3 plus 27x square minus 9x square plus 12x minus 14. And at the fourth step, 18x square plus 12x minus 14 equal to 18x multiplied by x minus 3 plus 54x plus 12x minus 14. Finally, at the last step the result is 66x minus 14 equal to 66 multiplied by x minus 3 plus 198 minus 14. Remainder is then 184. Answer is option B, 184. Instead of writing all these steps, you can reach the remainder quickly by keeping track of the compensating second term of each factor taken out. At the first step of this quick method, it will be 3x to the power 4. At the second step, 9x cubed. At the third step, 27x square minus 9x square, that is 18x square. At the fourth step, 54x plus 12x, that is 66x. And at the last step, 198 minus 14, that is 184. Important concepts and techniques used for solving the problem are continued factor extraction method and division and remainder concepts. This method is apparently time consuming, but with practice, it can be done quite fast. To read the detailed solutions, refer to the corresponding article in our website suresolve.com. Link is given in the description of this video. And please don't forget to subscribe to our channel for latest uploads. Thanks for your time.